Going to talk about multi-threading in Java. I'm recording this video because some student asked me to do that. So I will use also Copilot with us, and not Copilot, to use Gemini to support me as well. So let's go ahead and use Gemini. Excellent. Good morning, Gemini. I'll be recording a video for my students, so be there, and when I need some help, I'll ask you.
Good morning. I'd be happy to help you with your video for your students.
Thank you.
What do you need assistance with?
Okay, thank you. Dear student, so we're talking about multi-threading. Multi-threading is needed when you want to run more than one instance of your software or method or apps together. They're running together, and you can see this into gaming because so many objects will be moving on the screen at the same time, not one waiting for one to move and then the other. You can see this in trading because multiple stocks and things, their data keep changing, and you see it on so many systems. And to do that in Java, there are two ways to do it, and we'll go through this one quickly. So I'm in Rebel now. I will go and create a new file, and we will call it counting, maybe, yeah, counting threads. So we'll show you how we can count multiple threads while they are running at the same time. And to do that, we need first to create the class, yeah? So we'll call the class the same name as you know, class counting thread, and we will extend thread. You see the word here, extends, means we're using a thread class, which already in Java or abstract, and we are going to extend it to create our own class. This other way we can implement runnable, another one. Now what is important here is there is a method in the class called run, is the one that when you call the thread, it's the one that run. So we need to override that method. But before doing that, let's just create one attribute. We call it maybe work name or something like that, so we can check the name and we can see some data coming on the screen. So I'll make it private, and we'll make it final. We don't want to change it after we create it, and it's a string, and we can call it work name. This is just a variable. You can call it anything, and you can create any variable you want to do. Because we have one attribute we created here, we need a constructor, yeah, because to initiate that one. So this is the constructor. It's a simple constructor that we want to create. We need to call first the super class and send to it that worker name. That's one thing, because that's important. And then the next one, we can set this worker name, and this way the constructor is done. So this is a constructor. If you want just to add here a node, we can add a node, constructor, and we know it's a constructor. Why? For a number of things we know. First, the name is the same name as the class name, and the second, it doesn't have void or string or anything here, and it set the variables. What's more important is now overriding our run method. This run method is the one that already in thread, and we need to override it. If you don't override it, you will be using the basic one there, and it's not going to help us what we want to do in this case. So here we can have a very basic for loop just to test this, and we can just say for loop, and we'll have a system out println. I leave it at this level we're not going to add sleep and other things, so we don't need the try. Just I will leave it at this level, and that will be good for our illustration now, where we can illustrate how things will work. Okay, and later we'll come back and show you some more things we need to do. So let's come to the main class now. So this is a very basic thread class. One, we extended thread. We had one attribute here. You can have it final, not final, whatever you want to do. And then you need to set those data for the attribute by calling the super class, passing the same name to it, and then setting this worker one to this one. Okay, and this way we are done with our class. If you go to the main class, now in the main method, what we can do, we can create objects now of the thread which we created. So what is the name of our class? Is called counting thread. It is a type of thread. So I can't just declare it as a thread. I'll call it T1, show you that one. And then new what? We will call the constructor of that thread. And then we can have 1 and 2. Let's say 1 and 2. Now we created just two objects. Object 1 of type thread. I could have used counting thread as the data type here. That will work as well. Yeah, but I'm just going to show you that you can also go to the super class and use it to declare your data type. Okay, now we can call it. How to call it? The method here is called run, isn't it? But if I want to call run, if I call run, it will run a normal, not like a thread. But if I call start, which T1 called start, now if I do this, this will call, or T2 dot start as well, this will call the run method, but the run method will run in a thread format. Let me show you what I mean by that one. Let's run it just now and see what's happening. Now, because first time you run on Replit, you get this, so don't worry about that, because it's just preparing library, preparing things to work. And now, here is it. So the way it ran thread 2 from 1 to 9, and then thread 1, which we have here, from 0 to 9. Okay? Now let's run it again, see what will happen now. You can see now it's running like a thread. So running first 2, and then moving to 1. Then 1, then 2. Yes. Gemini, please.
Now that you started the threads, the operating system scheduler determines how and when they execute, which can lead to that interleaved output you're seeing.
Exactly. So you're not going to expect them, we're running them together. They are running together. In a normal way, it will run 0 to 9 for thread 1, and then 0 to 9 to thread 2. That's the normal way, in sequence. Because now it's threading, it's using the operating system, as Gemini said, to run it in a threading way. So a threading way means it starts the first one, maybe at the same time it wants to run thread 2, and then thread 2, then thread 1, and it goes together running at the same time, and you get the data like this. Okay? If I change it to run, just let's see the difference now. I'll use just run. Just remember this data we have now here on the screen. Maybe I'll just take a screenshot of this one, which is running in multithreading.
Okay, go ahead. And taking a screenshot can be a good way to capture the current state of the output.
Yes, so we're doing that. Let's run it now. And what you see now, running thread 1 and from 0 to 9, thread 2, 0 to 9. But in our previous example, which we run here, let's show you the two beside each other, hopefully. and I'm not able to do that, but I will show you here. So this is when it was running in multi-threading. Thread 2 started and printed 0. And then thread 1 started, the two are together, but we cannot display them together on the screen because they have to be displayed one after the other. So the two are running together, and here the two running together, here the two running together, and you can see, and running. But in this case, because I'm calling run, it runs it in a normal sequential way. So it goes with thread 1, and from 0 to 9, then thread 2, 0 to 9. So if you want your code to run as multi-threading, you should use start, not run when you call the run method. You still need the run method. So let's make this one start. Gemini, can you explain this better than what I did?
Certainly. When you use start, you're initiating a new thread of execution. This allows the two threads to run concurrently, and the operating system scheduler decides when each thread gets to run, leading to that interleaved output you observed. On the other hand, when you call run directly, it's just like calling any other method. It executes sequentially within the current thread, so you get a predictable non-interleaved output. In essence, start starts a new thread for execution, while run simply executes the code within the current thread.
Okay. To see it on the screen better, we can add here a sleep. Sleep means ask the system to wait for some millisecond, and after that, it continues. So we'll use try here, and let's do here. We'll come here. Sorry. We'll say try, and then we will put sleep inside. So how you do sleep, you call your thread. We have a thread here, sleep, and we give some millisecond. These are in millisecond. Why we need try? Because something could happen wrong when you execute the code if you when you call sleep. So better for us to have try and catch. And then we can say, we can display a message here, or say, we display just a message, simple message, system.out.println, a thread has been interrupted, yeah? Now, with this additional thing, the loop will not just continue like that. It will wait for 1000 milliseconds, and then it will continue. So if I run the code, let's see what will happen now. I think this is too fast. The system, maybe we need to increase this to, yes, still too fast on here.
Okay, so you want to slow down the execution of the threads. You can increase the sleep duration in the thread.sleep method. Currently, it's set to 10,000 milliseconds, which is 10 seconds. If you want to slow it down further, you can increase that number. For example, you could set it to 20,000 milliseconds for 20 seconds.
Yeah, so that's the way you can control the speed of running your software. And just we need, in the catch, we need return. That's something we missed.
Yes, adding a return statement in the catch block helps to stop the thread's execution if an interruption happens, preventing it from continuing to run after being interrupted.
Yes, yeah. So this will return back and keep it running, so do not stop. Okay, so basically this is what we did. What we could have done instead